So this exercise is related to topic momentum. And the first 4 questions are basically multiple choice questions, MCQs. And you can also use a chat to state the answer. I will solve these questions for you, but you can use the chat to state the answer. So an object is there. In the question, there's an object of mass 50 kilogram. This is the mass of an object. It was moving at a speed of 2 meters per second. Then it changes the speed to 10 meters per second in the same direction. We need the impulse. So whenever we need the impulse, impulse refers to a change in the momentum. These type of questions, better you just make a rough sketch to have understanding how, like what happened for the object to the object. So example, we have a 50 kilogram object. This object was moving at a speed of 2 meters per second. Then the object does not change the direction. So the chat is open for you. You can use the chat to state the answers. Answer for this one especially. The object speed changes from 2 meters per second to 10 meters per second. We need the impulse. So how to get the impulse? Impulse is the difference in the momentum, the final minus initial, and the direction does not change. So initial momentum is how much? It is equals to 50 multiplied by 2, which is 100. The final momentum is 50 multiplied by 10, which is 500. If the direction does not change and I need the impulse, so impulse is equals to the final momentum minus the initial. So if it is 500 minus 100, that's equal to 400. So B will be the right answer. Yes, Mohammed Ashraf.
Sir, also I made 10 minus 2 equals 8, and I made 50 by 8 equals 400. Is it true?
Yeah, that's also a way, because impulse is the final momentum, which is mv minus mu. Mass is not changing, so we can say impulse is equals to m is common, so we can say impulse is equals to mass into change in velocity. So it's the same thing. You just take a difference of the two velocities and multiply it by the mass, or you first multiply mass with velocity, and take a difference. It won't make difference to the final answer. In question 2, a bullet of mass 0.1 kg travel horizontally at a speed of 600 meters per second. It strike a stationary wooden block. So means whenever object collide, whenever object hit each other, we will always use the conservation of the momentum. So we will always, it means how to solve such question as one object hit another. So first thing I should write that the sum of the momentum before the collision So when two objects are colliding with each other, the sum of the momentum before must be equal to sum of the momentum after the collision. Now, we have to use as the conservation of momentum. So we have to sketch a figure for this. So there's a bullet. So example, a bullet is there, which is having a mass of 0.1 kg. And this bullet is moving at a speed of 600 meters per second. It strikes a stationary wooden block. So there's a block of wood. Like say this is a block of wood. The mass of the wood is 1.9 kg, 1.90, 1.9, but this is stationary or not moving. So 0 meters per second. This is before collision. After the collision, like when they collide with each other, the bullets stay in the block. So if the bullet stays in the block, it means bullet and block both will move together with the same speed. If objects stick together, object come in contact and move with the same speed. So means the speed, the final speed at which the bullet is moving and the block both will have the same speeds as a bullet stuck into this block. So what is the total momentum before collision? So 0.1 into 600. So 0.1 into 600, that's equal to 60. So the bullet, this is for before, like this side is for before, this one is after. So this is 60 plus the block was initially stationary, so 0. What is the momentum after collision? They move with the same speed as if the bullet stuck. So the mass of the bullet is 0.1 and the speed is v, plus the mass of the block is 1.9 and the speed is also v. So when we simplify, this will be 60.1 plus 1.9, that's equal to 2v. 2 is multiplied, other side it will be divided. So it will be 60 divided by 2. So 60 divided by 2 means we'll get 30 meter per second. That is the speed at which the bullet as well as the block will move. In question 3, an object is there of mass 60 kilogram. It decelerates when the resulting force of 300 Newton act. How long does the force act on it? You can use the conservation of the moment. You can use the impulse here to work out the force. Like first work out the impulse and then impulse is force multiplied by time. Or there's also another way, using a formula F equals ma, you get the acceleration, and from acceleration you will find the time. Both ways will give the same result. So an object is there which is having a mass of 60 kilogram. This object moving at a speed of 50 meters per second. It changes the speed because it decelerates, the force is opposing the motion. So it slowed down to 20 meters per second. The mass does not change for an object by a force of 300, resultant force of 300 Newton. So how long it take? So first what we'll do, we'll find the impulse, the change in momentum. So how much is this? The initial momentum, 60 multiplied by 50, 6 multiplied by 530. So this will be 3000. And what about the final? So 6 multiplied by 2, 12. So it will be 1200. So when we calculate a difference, the final minus initial, so it will be 1200 minus 3000, which is equals to 1800 Newton second. That's an impulse. It will be negative, but we don't have to consider a negative sign, as we just need a magnitude. We need the value for time. So now after getting an impulse, so impulse is equals to force multiplied by time. So we have the impulse 1800, we have the force 300, so we can find the time. So 1800 divided by 300, this will give us the time. So 18 divided by 3, that's equal to 6. So option C will be the right answer. This is when we use an impulse and we get the answer, like using the first impulse and then impulse is force into time, we work out the time. I can also use a formula F is equals to ma to get the time. It won't make difference to the final answer. Like first what we will do, we'll use the formula force is equals to mass multiplied by acceleration, the resultant force. Resultant force is equals to 300. Mass of an object is 60, acceleration we don't know. So 300 divided by 60, this will give us the acceleration, which is equals to, so it will be 5 meter per second square will be the acceleration of the object. After knowing the acceleration, acceleration is equals to change in velocity divided by time. So if you need the change in the velocity, the difference in the velocity, that is 30. Time we don't know. And acceleration is equals to 5. So we cross multiply, like t will be multiplied, 5 will be divided. So t is equals to 30 divided by 5, which is equals to 6 seconds. Yeah, force is a vector quantity. Why I did not put a negative sign here? Because I need a magnitude. If they ask what state the direction of the force, normally when we are solving a question, even though force is a vector quantity, if it is increasing the like it is in same as the direction of motion, we take positive. Otherwise, we took as negative. So I can take that negative. It won't make difference. The main thing is we are finding the magnitude, the value instead of the sign. The next one, a moving ball which is having a momentum of 25. So they mentioned it's having a momentum of 25. It rebound with the same speed. If rebound with the same speed, only thing will what happen, its direction of the momentum will change. But the value, the magnitude does not change. And whenever the direction changes, if the final you consider positive, the initial one will be negative. So we need the average force and the time is 50 milliseconds. So 50 divided by 1000. So 0.05 seconds. So what we will do, first we'll find the impulse. Impulse is the final momentum minus the initial momentum. Or when the direction change, we can simply add the momentums. So this will be 25 plus 25, which is equals to 50. So we have the impulse 50. Then impulse equals to force multiplied by time. So impulse is 50, force we don't know, and time is 0.05. So 0.05 is divided, multiplied, other side will be divided. So it will be 50 divided by 0.05. So D will be the
equal 1000.
1000. So D will be the right answer. So if direction changes, to get the impulse, we simply add them. If the direction does not change, we subtract to calculate the impulse. And then impulse is force multiplied by time. So impulse divided by time will be equals to the applied force. Then these are the structure questions. Paper 4 questions. Figure 2.1 shows a dummy of mass 70 kilogram used in a crash test to investigate the safety of a new car. The car approaches a solid barrier with a speed of 20 meters per second, means the speed at which the car was approaching a barrier, that is 20 meters per second. It crashes into a barrier and stops. So this car, when it hits the barrier, it stops. Calculate the momentum of a dummy immediately before the crash. Look, if the car is moving at a speed of 20 meters per second, what is the speed of the dummy inside the car before the collision?
It will be also 20.
It will also be 20 because even like example, if you're traveling on highway and you're moving at a speed of 110 kilometers per hour, like your car is moving at 120, so 10 kilometers per hour. So it means your speed is also 110. So speed of the objects which are inside is same as the whole. So we need the momentum of a dummy immediately before the crash. So the mass of the dummy is given in the question, the beginning, that the dummy is having a mass of 70. So mass of the dummy is 70 kg and the speed is 20. How much is the momentum of the dummy? The mass is 70 multiplied by 20. It will be less because approximately the dummies are away. No, it's not like this. Even if there's an object here, that will also move at 20 meters per second. It is not like the relative position of the object inside the car. they all have the same speeds. So it's 70 multiplied by 20, which is equals to 1,400 kilogram meter per second. So that is the momentum of the dummy before the collision. Determine the impulse of a dummy. Impulse means the final minus initial, like final momentum, because the dummy, as I mentioned, when the car approaches a solid barrier, it crashes into a barrier and stops. So the final momentum is 0. So impulse, you already work out the momentum before the crash. This was 1,400 kilogram meter per second. Then you need the impulse. So impulse is equals to the final momentum minus the initial momentum. So final momentum is 0. The initial momentum is 1,400. So we'll get as negative 1,400 and unit of impulse is Newton second. In a crash test, the passenger compartment stops in 0.2 seconds. We need the deceleration. Acceleration and deceleration is the same formula. That is the change in the velocity divided by time. The dummy, the passenger compartment was moving at a speed of 20 meters per second. That is the starting speed. When it hits the barrier, it stops. So final is 0. So initial is final is 0, initial is 20, and how much time it took? 0.2. So it will be minus 20 divided by 0.2. What's the answer for this?
Negative 100.
Negative 100. But because they already mentioned deceleration, so I don't have to write negative. I can just write 100 meter per second because they already specify it's a deceleration. So deceleration should be negative. It's all obvious it is negative. So if you write 100 meter per second square, you will score the marks. It won't make difference. Then the seat belt and the airbags bring the dummy to rest so that it does not hit the windscreen. The dummy has an average deceleration of 80. Calculate the average force applied. So how to work out the average force? We have the formula F is equals to ma. Force equal mass multiplied by acceleration. So mass is 70 and deceleration is 80. So when we multiply them, 7 multiplied by 8.
So Mr. 5,600.
So 56 and then 00. So 5,600 Newton. So when you have the acceleration or deceleration in mass, you just multiply them to get the resultant force. And the deceleration of the dummy is less than the deceleration of the passenger compartment. Explain why. This is of benefit for the safety of the passenger. Means like when in case of the car crash, the passenger compartment is like it's having it's different deceleration as compared to that of a dummy. What is the advantage of that? Because if deceleration is small, it will take longer time to stop. So because we have the formula acceleration and deceleration, which is a change in the velocity divided by time. So if the object is having a smaller deceleration, it will take longer time to stop. Or if object is taking longer time to stop, it means it will have a smaller deceleration. If it's a smaller deceleration, the force which the passenger or the dummy will experience, that will be small. And if a small force exerted on the person or a passenger, this will reduce the chance of serious injury. Otherwise, what might happen if the object stop instantly, then he will experience, it will take a short time or experience maximum acceleration or a resultant force which leads to a fatal injury. So that is the advantage of using a seat belt. Seat belts increase the time for object to stop. As a result, what will happen? The resultant force will decrease, which is an advantage. Otherwise, if the resulting force were higher, then it may lead to a serious injury. So this question, as you can see, two trucks are there, A and B. So whenever the objects are colliding, to get the speed of one of the object, we normally use the conservation of the momentum. But the first part is most of the time is just getting the momentum of moving object. So figure 2.1 shows two railway trucks on a track. The truck A is having a mass of 6,000, which is moving at a speed of 5 meters per second. That approaches the truck B, which is not moving, so it is stationary. Calculate the momentum of truck A. We need the momentum of only truck A. How to get the momentum?
Mass multiplied by velocity.
So it will be 6,000, the mass, and multiplied by speed at which it is
30,000.
So this will be equals to 30,000. And the unit of the momentum, kilogram meter per second or Newton second. Because momentum or change in momentum, they can have the same units. If the object is, one of the object is stationary. So the next part, the truck collide, their buffer compresses. Buffer springs are there, which compresses. So they bounce off each other and remain undamaged. After the collision, the truck B is having a momentum of 27,000. Determine the impulse. Look, what is they mentioned, like this is before collision, but after the collision, the truck B is having an impulse of, truck B is having a momentum of 27,000. So what is the momentum of truck B before the impact?
0.
0. Yeah, it is 0. Why? Because it was stationary. So stationary objects will have 0 momentum because the velocity is 0. Final is 27,000. So when we work out the impulse, it will be 27,000 minus 0, which is equals to 27,000 itself. And Newton second will be the unit. The next part, the trucks are in contact for 0.6 of a second. Calculate the average force. So if we know the impulse, as we calculated the impulse here, which was 27,000, we have the time, we need the force. So impulse equals force multiplied by time. So impulse is 27,000, force we don't know, and the time is equals to 0.6. 27,000 divided by 0.6. What's the answer? How much is the
45,000.
so impulse is force?
45,000.
Okay, 45,000. Thank you. So impulse will be equal to force into time. So when we divide, it will come out as 45,000 Newton. Then the next part, we need the final speed of the truck. So whenever you need the final speed, I will solve on the same page as this one. So we need the final speed of the truck. So whenever you need the final speed, you will always use the conservation of the momentum. So according to conservation of the momentum, the total momentum before must be equal to after. So momentum before, this was stationary, so the momentum was 0. This was moving, 6 multiplied by 5. So this was 30,000. So momentum before is 0 plus 30,000. What about the momentum after the collision? So they mention when they collide with each other, the impulse or the momentum of the B, that is 27,000. They already provide the momentum. What about the momentum of A after the collision? So the mass is 6,000 multiplied by speed is V. So the total momentum before collision is equals to total momentum after collision. So we'll simplify this. So by using a conservation of the momentum, the total momentum before equals to total momentum after the collision. So before it was 0 plus 30,000. And after it is 27,000 plus 6,000 NV. Now we simplify this. So this is 30,000, 27,000 will move other side, it will become 3,000. So 3,000 is equals to 6,000 V. 6,000 is multiplied, other side will be divided. So 3,000 divided by 6,000 is equals to V. So 0.5 meter per second is equals to V. So V is equals to 0.5 meter per second. So that's how we work out the speed of the object. Then figure 2.1 shows two cars are there. So as you can see, a common pattern is there that when two objects are colliding, one of the object is stationary. The car B is having a mass of the car B, like two cars are there, car B, which is a mass. So this is 1200. This is car B. And this one is car A with a mass of 2000. It's moving momentum of A. What is the momentum of car A before it
36,000.
36,000, because it is the mass is 2000 multiplied by 80. So 2 multiplied by 80, 36. And then 30, so 36,000 Newton second or kilogram meter per second. I can write both. Then the car collide and the car B experience the impulse. The car A continue to move with a momentum of 21,000. Calculate the momentum of B after the collision. So how we can, because we know the total momentum before must be equal to total momentum after. So they mention the car collide and the car B experience an impulse, like there's a change in momentum. A continue to move in the same direction with a momentum of 21,000. So the total momentum before must be equal to total momentum after. So we will simply, before the collision, this was 0. This is 36,000. After the collision, we don't know its momentum, x, and the momentum of this one is 21,000. So we know the total momentum before and the total momentum after must be same. So it will be 0 plus 36,000, because this time we need the momentum only, not the mass, not the speed, the product. So 0 plus 36,000 equals to 20 x plus 21,000, because they mentioned the momentum of A after is 21,000. So we just subtract, like we need x here. So 21,000 is added, other side will be subtracted. So 36,000 minus 21,000, which is equals to 15,000. So 15,000 Newton second or 15,000 kilogram meter per second. Then determine the average impulse. So if we need the average impulse, because B was stationary and then 15,000. So when we calculate the impulse, it will come out same because 15,000 minus 0, it's equal to 15,000. Why? Because the car B was initially stationary and final it is 15,000. So that's why the impulse is 15,000. And using the impulse, you can find the force as well. Like force, impulse is force divided by time. So